Welcome! We are Ignacio Orozco, Ana Cristina Vega, and Nicole Pacheco, and this is our STEAM's animation. So, first of all, what is an exothermic reaction?
An exothermic reaction releases energy from its surroundings, meaning it releases heat and has a negative charge in enthalpy.
Some examples of exothermic reactions involve combustion, oxidation, and changes in the state of matter.
On the other hand, an endothermic reaction absorbs the energy in the form of heat from its surroundings, meaning positive charge in enthalpy. So, what is enthalpy? Enthalpy is the heat change at constant pressure using the formula delta H equals to QP.
In endothermic reactions, they have a positive delta because it's gaining energy. On the other hand, exothermic reactions, the delta will be negative since it's losing energy. So, what is a chemical reaction?
A chemical reaction is a process that one or more substances go through and result in change. The reaction has two parts, the reactants and the products. The reactants are the compounds on the left side of a chemical equation, and the products are the ones on the right.
Our chemical reaction is hydrochloric acid and sodium hydroxide, which is a neutralization reaction.
The elements that compose this reaction are a strong acid and a strong base. The strong acid is the hydrochloric acid, and the strong base is the sodium hydroxide, resulting in one being water and the other salt.
Now, let's see this reaction on a microscopic level. When hydrochloric acid and sodium hydroxide react with each other, in order for the atoms to separate, energy is absorbed, causing chloride in the hydrochloric acid to bond with the sodium in the sodium hydroxide, resulting in salt and water.
The bonding of these elements releases energy, making this reaction an exothermic reaction. Bonding energy plays a big part in these reactions, since without the release of energy, it wouldn't be an exothermic reaction.
How can we find how much energy is absorbed and released during this reaction? First, we research how much energy is needed to break each bond of our reaction. Now, having that, we add the amount of energy from the two reactants and from the products. Finally, we add the total of reactants and the total for the products. The final answer is negative 95.9 kilojoules per mole. This reflects a negative delta and demonstrates that the reaction is indeed an exothermic reaction.